Hey everybody, thanks for coming back after lunch. I know we all had lots of food and wine and stuff, but we're going to be talking about something that I find really exciting this afternoon, and hopefully you do too. The title of this talk is SVG Can Do That. Part of the reason why I'm giving this talk is because SVG as a graphics format is just capable of so much, and I think we're just at the tip of the iceberg for really touching on all of those capabilities. So yeah, like I said, my name is Sarah Drasner. This is a photo of me as a child and my mom and my relationship with authority. I'm a senior developer advocate at Microsoft. I just started, so that's exciting. And I just think SVG is a total party. You can kind of make your party yourself, or you can have JavaScript be the event coordinator. Get it? Event. OK, there's going to be lots of bad jokes where that came from. And we can do so many cool things with it. So some of you already might know the benefits of SVG, but just in case you don't, let's go over some of those. It's crisp on any display. It's built with math. So basically, anytime you're making an SVG, you're just plotting a few coordinates, and the computer is drawing all those coordinates out for you. So it's not like bitmaps, where if you make something really big or really small, it loses clarity, and it kind of loses pieces of it. So that's really nice. It has less HTTP. I always mess that part up. Less HTTP requests to handle. Did it. All right, cool. It can have no HTTP requests to handle because you can have it directly inline, unlike other images where you have to make requests from other sources. As we move into HTTP 2, this is less of an issue, but we're not quite there yet. So for the time being, SVG is really awesome for that. It's easily scalable for responsive. One of my favorite things, it's in the name, scalable vector graphics. That means that you can make it adjust to any kind of viewport, and we're definitely going to be doing stuff with that today. It's a really small file size if you design for performance. If you design for performance is an important part of that, so we'll talk about that today as well. It's easy to animate. Again, one of my favorite things. I wrote a literal book about that. It has a navigable DOM, which means that you can reach right inside of it and move certain pieces around. So if you have a flat image where everything is just kind of presented in front of you, in order to make an arm move or something, you'd have to go in and cut out pieces of it in order to kind of move them around. These are literally just DOM nodes that you can slap classes on, that you can do all of the same things that you do with HTML elements with. So that's really cool. We talked about how it has a navigable DOM. It also can be accessible because it has a navigable DOM. And it's fun. Remember when we used to have fun? Fun's cool. Yeah, cool. All right. So with all of the pens that I'm going to be showing today, I made all of these demos, but I'm going to be showing you some work that other people made as well to kind of showcase them. But I'll definitely have their names at the top of them, and then also I make the slides open source, so you can check them out later. SVG is such a flexible medium. We can do so much with it. We can manage state even within it and do all sorts of beautiful effects. So I actually hope that this is the last year I have to show this slide. People think that SVG is really not well supported because years past it wasn't, but look at all that green. We got Opera Mini. We never get Opera Mini. That's just amazing. And it says IE 11 there, but it actually goes back to IE 9 with partial support on IE 8. I don't know why CanIUse doesn't show you all of that information. But if you're not using SVG because you think it's poorly supported, you can update that information in your mind as well. So what does the scalable mean when we talk about scalable vector graphics? You can see here we place the graphic directly inline in the HTML, and it has width and height attributes, which keep it to that size. But then when I take those out, it adjusts and it fills that entire area, which means that if I wanted to make it constrained to the viewport width or the viewport height, I can do so. Or if I want to put it inside of a flexbox or grid or percentage, you name it. So that's really nice because everything stays totally consistent. And Is positioning in CSS keeping you down? Well, sometimes it kind of bothers me. SVG might just be your answer. You saw all of those things that were inside of the SVG were staying exactly at their coordinates no matter what we were doing to it. That's really awesome for positioning. You can kind of just throw all of the crazy CSS stuff to the wayside and position things within SVG. It even has text. As a side note, I did this to myself on the plane on the way here. I was drinking wine and watching a horror movie and splashed it in my face. Anyway, SVG allows you to create advanced effects like this type lockup, and it can look really slick and professional while still using actual accessible text. That's so nice for responsive. Which also means that in terms of animation, we can create something that's fully responsible and scalable in every direction, and the animation values are working within that coordinate system. So they'll stay totally stable even if you're changing the sizes of them and moving things around and adjusting it. These type of positioning refinements are really, really wonderful if you have a ton of information on smaller screens like mobile and you don't want to show all of the information at once. If you have tons of icons and you need to kind of collapse that view, you can do really advanced layout effects where you're showing and hiding that information with only a small amount of kilobytes. So it doesn't necessarily have to be, squishy either. We don't just squish things back and forth when we make responsive design. Let's do some real responsive design. So I made a Huggy Laser Panda factory because, we need to know where Huggy Laser Pandas come from, and that's where they come from. So if we have the Huggy Laser Panda on desktop, it's actually comprised of 3 different SVGs. We've got one for the top part, and one for the side, and one for the other side. And then on mobile, they're going to stack and reconfigure. You can see that middle part, that one on the side that's magenta, is actually just being transformed, translated, and kind of moving over to the side. So if we have the Panda factory running, we have our panda getting painted to be a panda, then we have our panda getting lasered, and then we have our panda getting huggied, like you have in real life. And then when we scale it down to mobile, everything can kind of reconfigure and reconform. And all of this works on old Android devices, old Windows phones, and it's only 13 kilobytes. So if we look into the code here, what we'll actually see is that I have a timeline that's wrapped in a function that's named appropriately. In this case, the naming it appropriately is like function paint panda. And I really literally have a click event listener to re-trigger that timeline. But you'll see all of the functions are scoped to the SVGs itself. So the design and the functions are all organized in the same way. So if I need to update something, everything stays totally organized. We can also use that stability for page transforms. So React is really awesome because it helps us manage state in a really responsible manner. I made this with React and GreenSock. GreenSock is an animation API. React coordinates the state, while GreenSock coordinates all of the intermediary values. So we're showing the transition from page to page, and SVG will stabilize all of our graphics while we do so. So in this example, I have this concept of screens. I'm toggling the screens forward, and then they wrap back around to the beginning screen. And then we have a timeline function that can choreograph all of the animation. But something that's really cool about the GreenSock animation API is this thing called SVG origin here, or this thing called clear props here. The clear props will actually allow us to remove any inline styles that are set on that element or that DOM ref. So I can remove those if we need to recalculate values or put it into another position. So here's another one I made with Vue and Nuxt, which I love. Vue is a front-end framework that is very similar to React in that it's the V of MVC. You probably are familiar with it. Nuxt is a really quick and easy way to get server-side rendering with Vue, and it allows you to do routing and all sorts of code splitting without stepping outside of a Vue file. And because we're using SVG for all of these animations, everything stays totally stable. Nuxt also gives us page transition hooks, so we can hook into the animation and make it different per page. So all of the ways that the mountains are changing and the text is changing changes per page. So if you'd like to check out the code, I have a repo for it and also a demo site that's live that you can check out too. I'm showing the slide so you can get a sense of how those JS hooks work. We have these different page routes, and if you want to plug into them, there's a bunch of different page hooks per page. The one that's really important here is this transition mode, and that's super cool, because when you have a transition mode in Vue, what it will do is it'll allow that component to completely unmount, but it'll wait for the animation to fully fade out, then it will unmount, and the other thing will wait until it's done. So you don't have to write any like messy callbacks, which is what you usually end up having to do when you write that kind of code. So this is from Code Drops. It's a similar concept, but it's built in a different way. The fixed content lies beneath, and once we move the content up, it gets revealed. And all at the same time, that SVG path is changed through path data ID. And this is done with anime.js, not GreenSock. This pen by Sullivan Nolan uses transitioning effects and morphing. This is back to GreenSock's Morph SVG. And you can see how it's really captivating. And again, because we're using SVG, it stays totally stable for mobile. But we can also use SVG for the layout itself. When we were making this page for web animation workshops, our branding is all these triangles, so we wanted to make some interesting page layouts. Those little triangles between the sections are little pieces of SVG where we've said preserve aspect ratio none, which means that it's always going to scale in every direction with the container. So usually you don't want that, right? If it's like a face or something, we don't want that. It's going to be like, and that's a technical term for that. But in terms of page layout, that's exactly what we want. Cool. So SVG can also be super tiny. If you look at this HTTP archive graphic, it's a breakdown of all of what we're transmitting over the web, right? All of the kind of content breakdown. So we've got a bunch of video, we've got a bunch of fonts and scripts and style sheets, but images is huge. Images is 2/3 of what we deliver over the internet for everybody. So I love this quote. You can't be a web performance expert without being an image expert. It's actually pretty true if you think about it. If you think about that last graphic, if you're not thinking about the size of your graphics, then you're really doing yourself a disservice. I used to be a consultant before I worked for Microsoft, and this company hired me because they had 10-second page load times. And just by optimizing the SVGs on their site, I brought the site speed down to less than 2 seconds. That's all of those seconds of deployment and performance all came from the graphics. So how did I do that? Well, not all SVG graphics are created equal. We have everything drawn with math, but if you have tons and tons of path points and you're not optimizing correctly, it can really bulk your files. So I really like using SVG OMG. Again, these are like linked up in the slides if you want to check them out later. SVG OMG is by Jake Archibald. It uses a lot of service workers. So if you have a bunch of settings in it, it will remember the next time you go there, which I think is super cool. It uses SVGO, the last one under the hood, which is terminal-based. So if you're more comfortable with your terminal, you can use SVGO. But I suggest you pair it with SVGO GUI because the way that you optimize actually affects the way that that SVG will look. The middle one is Peter Collinridge's SVG editor. It's like a 15-year-old Rails app that I just keep in there because like I'm a neckbeard and I like it still. Probably a little less useful, but really, really still kind of fun. I also wrote a post for CSS Tricks called High Performance SVGs. That was all of the process that I went through to reduce the size of those SVGs for that consulting gig. So in this pen, I have this little draggable thing, and it's a little spaceman, and he's standing on the moon, and the cow keeps scaring him as he goes over the moon, and it's touch-enabled for mobile, and that whole SVG is 2 kilobytes. So you can do really kind of cool effects and show really, really interesting information and have things be super small. So while we're looking at this, let's take a gander at what's happening under the hood, because I ran into a gotcha when I was trying to build this. So at first I was like, oh, okay, I'm going to make this like thing that's like a null object around with this cow, and then I can spin that, and it can also detect if there are collisions with like get bounding client rect or get bbox for that little astronaut head. But then it was firing all the time, and I was like, what's going on? I think the browser is wrong. No, the browser's not wrong. What was happening once I started, putting borders around it and kind of understanding this a little bit more, is that the browser doesn't see diagonals. The browser only sees in rectangles. So to give you a better idea of what that means, if you look at the bounding box stroke of these rotating elements, this is what the DOM sees. So I just think that's crazy. Like, look at that circle. That's so weird. So sometimes in order to debug things like this, you do actually have to think like the browser, not like yourself. OK, back to the weight of SVGs. Because they have the potential to be so small, SVG is the perfect time to use something like a loader. A lot of loaders are really ugly, and a lot of loaders are using GIFs, which are really heavy. If you have a heavy and ugly GIF, maybe you should think about updating it. This graphic, when I was given this graphic by the designer, this is for Smashing Magazine's checkout experience, it was 35 kilobytes, and I brought it down to 6 kilobytes just by optimizing it correctly. And that includes the animation and everything. So SVGs can make other graphics smaller. There's this thing called JPEG.svg, and by this guy named Shah. And this is not like a particular graphic that I found, but you can see that just dropping in any graphic that I had around, which is my I Am Happy Marge Simpson, we brought the file size from 38 kilobytes to 16 kilobytes just by switching it to an SVG and creating an image mask over the kind of repeated, images. If a bit mask has a lot of the same colored squares, it's still mapping out all of that territory, where an SVG can say, like, take the bounds of these things and don't paint them, just show this one color. So that's pretty cool. SVG can be accessible. We mentioned this before. There's actually like a ton of ways that SVG can be accessible, and it's like can be complicated. But 9 times out of 10, this is what you're going to need in order to make an SVG accessible. So I'm just going to dive into that really quick. So we write aria labeled by and then a title, and that title, it has to be the first thing that follows that SVG tag. That title also has to have a unique ID on it, otherwise it won't be picked up by JAWS and NVIDIA devices. Just writing title is not enough. We also have role of presentation on the SVG itself. What that'll do, even for your icons, you should be doing this, it'll allow screen readers to know that it's an image and not announce everything inside. If you wanted to announce things inside, you'd move that to role group. So that's some of the ways that you can make it responsive. I also like writing whatever language it is, so that if somebody's using a screen reader in another language, the computer does the hard work for them. That's pretty cool. So there's a resource with support charts. There's also this article by Heather that she wrote for CSS Tricks. She spent like every weekend going to the library, checking every different device, this whole big labor of love for the community. So definitely check out that article. She did a great job with it. SVG can be styled like text. This is kind of like not too fancy, but something that a lot of people kind of come to me and ask me about. So let's cover it real quick. Someone on Twitter asked me about this. They made an SVG sprite sheet, and they're not styling it along with the text. They wanted everything, if they changed that line of text, for it to pick that up. So really, so this is the question code. I left it exactly how it was. And the secret trick here that you may or may not know about is that you change the fill to current color, camel cased, and that will just make it reflect whatever it is. So right now, I just have that line with a class that says color red on it, and it's picking up that color. So if you are using SVG icons for your site, that's a really quick way to not have a headache whenever you're working with it. SVG can bounce. We can make a ball bounce with SVG really easily without any animation libraries using request animation frame. If we have this ball bouncing, we can use a little physics to kind of drum up the bounce of the ball, and we can make the radius bigger, and we can do all of that midstream. So I'm using Vue again here, and there's some info that I'm not showing here, but here's the gist of it. We've got data, we've got the total height of everything, we've got the radius, we're incrementing things based off of a click event, and then we have gravity that increases the vertical speed, horizontal speed increments from the horizontal position. All of these things I learned from just pulling things out of physics books. So you don't have to invent all of this stuff from scratch. You can steal ideas that have been around for a really long time. This pen by Tiffany Rayside is one of my favorite animations of all time. She's not using any library or anything at all. She's spinning up pieces of the SVG, applying physics and even these crazy bounces to it all. So she manipulates the SVG path values when it hits the wall. She's just kind of a master. So if you don't already follow her on Twitter or CodePen, you should definitely go do that. SVG can snap. In order to create some, really, really beautiful effects, we're going to use some ES6 template literals, which you're probably all familiar with, but just in case you aren't, I'm just going to say something about them really quickly. Previously, we had string concatenation, and all of that printed out to this, which was really hard to read, and it was kind of ugly, and it was kind of error-prone because it was hard to read. And now we have awesome template literals that when you put things in backticks, we can just manipulate strings really, really readily. And what does that have to do with SVG? Well, SVG, all of those paths inside of an SVG are really just a bunch of strings of commands, and they have these curve values. And all of the letters mean a certain thing and draw certain kind of curves and create certain kind of paths. So I really like this kind of Path Explorer tool. If you're not familiar with the way that SVG works, you can go and play with this. I also wrote about it in my book if you want to, something that's a little bit more traditional. And if we know enough about how those curves are made, updating them is very simple with something like template literals. When we're building out these paths, we start with a move to, and then we can create those curves by using things like C and Q. So we give it a handle, and then we give it another point, and the computer draws a curve for us. How cool is that? You can plot 3 points and the computer draws a curve. I just think that's great. So that's really neat. And then we can plot the points. We have a bunch of different coordinate values that we're updating. And it's so flexible. We can make effects like this. So you might have noticed that SVG was distorting at the end there. So let's kind of cover distortion really quickly and dig into how you can do that. So distortion filters are really awesome. There was this great code drops demo with a bunch of buttons, and definitely the most impressive technique was you hit a button and this little ripple effect came out. And what they're doing in order to create that is they're using a filter called turbulence. And you can animate this filter in JavaScript. You can't do it in CSS. It's not an animatable property. We're kind of hacking the spec here and manipulating it because there's just a bunch of numbers. But I would say that from manipulating filters and pushing the DOM's boundaries and stuff and doing things I'm not supposed to do, I would suggest setting the filter on a timer, applying it when you need it and taking it off when you don't, because it is performance insensitive. It's not really hardware accelerated. So we can make things like this pool. And that's pretty fun because the way that this is done is by applying that filter and using an image to distort anything that's beneath it. So we can have tons and tons of path values like you see here. Everything under the pool is also getting updated too, and we can do it really, really simply. All we're doing is we're taking that distortion filter and that image, and we're basically making it scale down, hit the wall, and scaling up, and we're also animating the filter. So we can do really, really crazy effects. And when I made this pen, I wasn't really thinking about the political climate. So it's it's kind of a weird one to show. But we can, by animating filters, we can also make things like a realistic candle that's drawn with math. That's really, really fun. In order to make this, I have a few different pieces that I just kind of traced off of a candle photo. So I just made this in Illustrator and then made a gradient that's attached to it. And then they're not actually blue, but I have a bunch of different path values that I'm going to set on a for loop, and I'm going to morph between those path values for each second and plot them along a timeline. But I also am using a filter, and it's this GUI filter that Lucas Beber created. So he has some prior art here. He's actually using this with divs. You can make an SVG filter and apply it to HTML. You don't only have to use SVG, so that's pretty cool. So a lot of people use this kind of GUI effect. It's a blur filter and a contrast filter applied at the same time. So yeah, we can, because that standard deviation of the filter is just using numbers, we can have JavaScript update those numbers. Request Animation Frame knows how to update numbers, so we can do that. We go through all of the path values, and then we've got a little math.random opacity because nature is just a little unpredictable. And then we can use that effect to create smoke with math. SVG can do on-the-fly logo adjustment. This demo was made by Leah Veru, who, if you don't follow her already, you should probably go do so because she makes all sorts of crazy great things. But basically, you're allowed to update these logos on the fly, which I think is super great. If you have to collaborate with a designer who keeps on not making their mind up, and they're like, oh, change it out here. Oh no, like fat is in, oh no, flat is in. You can kind of make all of these things really, really adjustable so you don't have to keep changing things up. And she made this with a tool called Mavo that she built. That's basically so that you can drum up sites using HTML and CSS with very little JavaScript, which is not very useful for us, but I'm pretty sure that almost everyone in this audience has a family member that's like, hey, can you make me a website? And if you do, this is a really good thing to show them, because with just a little bit of training, they can make their own website, and you can get on to your real-life work. SVG can draw itself, too. So let's say we have a shape, and the stroke of that shape is dashed. But we make the dash all the way around that entire shape. It's the length of the entire shape. That offset, the offset between those two dashes, is animatable. So we can have an SVG draw all onto the page just using CSS or something. So I made this pen to kind of celebrate New Year's. And there's like, the fireworks are that kind of idea, and pew, and yeah, that's. This pen by Chris Gannon is also really awesome. He does that same effect. If you don't follow him, you should go follow him, because I think he's just pretty much a genius. He's also doing this with ClipPath. It's super cool. You can also interact with an SVG. We can manipulate it and interact with it on the fly as well. So since it has a navigable DOM, you can do all sorts of things with it. Again, I'm using Vue here to update the text and make random lines and allow the user to kind of play with the SVG graphic as much as they want to. I can also animate it if I want to, and have them be in charge of that as well. And I made this demo too long, so we're all going to watch it. So it's going to play the animation. But the coolest part of all of this is I'm going to play this animation. It's still a graphic, so I can still download it. And it's going to respect all of the positions that were set during that animation. So even though I'm animating it, it's still in all of those places. It's still a graphic that they can hand out to their friends or something. So here inside the HTML template, we can create some semantic form elements, and then we can bind them to these methods where we're creating and kind of drumming up pieces of the SVG on the fly. We can use SVG to respond to things that the browser is doing. So we have this little WALL-E pen. I don't know if you've seen the movie WALL-E, but I really like it. He has a little cockroach friend, and he's kind of reaching out for him every time the user moves across the page. So what we have here, and we have a bit more code than that, but basically we have these @mouse move events, and I've created an entire timeline for him reaching his arms out, complete with eases, and then I plot that progress of the timeline along with the coordinates, so the user can control all of that, and it stays really, really lifelike. So in order to make that pen, we had to clip and mask things. So SVG can clip and mask things. SVG offers this thing called clip path, which is really nice because if you looked at his arms, they had to kind of reach out from somewhere, right? I can't just keep tucking everything behind everything else. In order to make it look realistic, it has to clip out parts of his arm. So we were able to do that with clip path. And if you use something called mask, you can use opacity. So clip paths will just kind of respect the geometry, but something like a mask, we can create something with like a GIF masking with all of these SVG patterns and slowly unveil them. We create a mask in defs and put inside of it the image that we want to use, and then we apply it to a rect that also has a pattern associated with it. So I learned this technique from Yoxel, who has like a whole bunch of pens like this that are super, super awesome. She also has the most comprehensive, collection of SVG and CSS clip paths. So if you need to learn about them or you're confused about them, this is all like interactive and you can play with it, and the code is open source. I also kept getting confused between the difference between clip paths and masks. So I wrote a CSS Tricks article that you can look at that defines the differences between them. CSS Tricks has pretty good SEO, so I knew I could just go look at my own resource again and again if I got confused again. And since SVG also has text, you can have that masking apply to text and do things like have your users update text too. This pen by Noel Delgado is probably the most famous and also my favorite example of this clipping and masking that's paired with animation. SVG can signify something changing. So I kept going in between different time zones for my work, and I couldn't remember where all my coworkers were or what time it was. And I could have just made a dial that just showed what time things were. But by changing the SVG and making that dial that associates that change in time, I get a better sense of whether or not it's day or night, and I can ping them or not, and they're probably with their kids or something like that. But while I was working on this, something interesting I found was I used to use this thing called moment.js that kind of allowed me to work with time data and understand where everybody was, in terms of like daylight savings time. But there's actually a native method called toLocaleTimeString that offers all of these defaults, like hours and minutes and all sorts of things. So that actually respects all of those daylight savings times. So you can eliminate a big library like Moment. You can use SVG's ViewBox as a camera. This is one of my favorites. You might already know this, but when you have something like a graphic, when SVG is plotting all of those points to draw those coordinates, it's doing so on a big piece of graph paper, basically. And that piece of graph paper is endless. It's just this giant coordinate system. And in order to see inside of that SVG and know where to plot those coordinates and what you're looking at, you have a thing called the ViewBox. And the ViewBox is made up of 4 values, 0, 0, that's x and y, where to start it off, and then width and height. So if I wanted to update this view box to just look at these little houses or something, I would have to update them to 215 by 160, 42 by 20. So SVG also has a native method called getBbox, and that will return this object that has x, y, width, and height for anything that's inside the SVG. That's cool. That sounds a little familiar. That might be what we need to maybe animate it or update it on the fly. So here I'm just using that to update the view box, and then if I take that out, it will go right back to where it was. So I'm just setting the attributes based on that. So then we can do something like this data visualization, where we're zooming in on a certain country in order to show different pieces of information. And again, because it's SVG, it's all totally scalable for mobile, and it's so small because it's just one path that's drawn. We can also make a flow chart. Basically, this is just a giant SVG, and we're just like moving things based on the user input, and then people can pick a certain thing, and then they can go to a different kind of output. So we can make interactive flow charts. This one is really cool. This is like a game that somebody made, updating the view box, where they're like placing little household items and stuff. But we can do better. We can do like a big game. So let's make a game, and that will be the last thing we do this afternoon. So if we have a game about a hipster elephant that's going to go get tacos, but his friends keep texting him to change plans, and you're supposed to try to go get the tacos, but avoid the text messages, and like there's margaritas for extra bonus points. Oops. So you can basically move this guy around, and like your heart meter goes up and down. And if you lose the game, you become hangry, and you have to watch a movie you already saw. And if you win the game, you can tweet out your score. It's based on real-life events. So how do we use SVG in order to create this? We're using React to manage all the state for that application. If you know how to manage state for an application, you can probably already make a game, too. So we're using SVG three ways. We have it directly inline in the HTML for loops. We have background images for things like tacos. We're not really updating the tacos. We're just kind of throwing them across, so they don't have to do anything super special. And we have things that are inline directly in React. So let's look at that last one really quickly. So if we have, this is a slightly older pen, so yes, I know I'm using React.create class. I wouldn't use that now. I would use class extends. So if we have the initial state of that score that's at 500, and then we're setting the game to start because they can play it again. They can get to the end and decide to replay. So we're setting the score back to 500 if they do so. We don't want them to have too much, winning too much or losing too much. And then we have this update score that will either end the game or win the game if it gets to a certain amount. But then, and my highlighter is not on this, it's on the dots, but it should be on the heart meter. And that heart meter, we're passing down this .state.score. So you might have noticed that heart meter at the top of the game that was kind of keeping track of our score. So basically, we have this SVG, and that SVG is actually really, really big, because I want to use whole numbers for this. I don't want to use 27.25 or something to update the score. I want to use 1,000 or 0. So it's really big. And then we have the width, that's this.props.score. And in our rect, in SVG, in order to update it, we have an x, y, width, and height, just like the bounding box. So we can update that on the fly. And because it's SVG, we can make it super small then for the size of the screen that we need. And on desktop, it's a certain size, and on mobile, it's a different size with media queries. All of that, and we didn't even get to any data visualization. I wrote a book about SVG animation. This is not my book. This is my friend making fun of me. I don't have a man blob animal. That's not even my last name. I do have a real O'Reilly book. I think I have a fancy chicken or something. That's cool. Yeah, thank you so much for coming today. I appreciate it.
Thank you so much, Sarah. Those animations totally blew my mind. And I love how you shouted out so many other creators in your talk. Way to spread the love.
Yeah, there's a lot of them.
We have time for one quick question. What resources would you recommend to get started creating awesome SVGs like the ones you showed?
Yeah, actually, I think a misconception that a lot of people have is that you have to be a designer in order to make things with SVG. You don't. There's tons of free SVGs online that you can go play with. Freepik, with a K, no CK. Freepik.com has tons of free vectors that you can use. The Noun project also has a bunch of free vectors, so you can just download them and start playing with them and animating them and manipulating them.
Awesome. Thank you, Sarah.
Yeah, thanks.
Definitely go buy her book if you want to learn more.